Hello everybody. So this afternoon we're going to go over section 5.5 in your book, Solving Polynomial Equations. So sometimes you have a polynomial that is not a quadratic, which means a quadratic is when you have a variable to the second power, and then you have the x, and then you have the constant. Okay, so a quadratic, yes, a normal quadratic would look like this. For example, x squared plus 2x plus 1. You have the squared term, you have the linear term, and then you have the constant. Okay, so sometimes we're working with polynomials that are not quadratic. The degree is maybe a 4 or a 6 or something like that. And so we're going to learn how we can rewrite those in what's called quadratic form and factor it and solve like a normal quadratic would be factored and solved. So I'm going to read through these notes and then we'll do some examples. Rewriting a polynomial equation in quadratic form is sometimes less complicated to solve. By letting u, or a different variable, represent some expression in terms of x, you can solve simpler equations. The equation x to the fourth minus 16x squared plus 60 equals 0 can be changed to quadratic form as x squared squared minus 16x squared plus 60. Okay, so then it goes on to tell you that you can substitute a different variable in for the x squared, and it'll be a quadratic, and then you can factor and solve like we normally do with quadratic polynomials. Okay, so looking at this last sentence, it says, if the degree of the middle term of a trinomial is not equal to half the degree of the first term, it cannot be written in quadratic form. Okay, so let's look at number 1 as an example. The first thing you want to do is look at your middle exponent. For this one, it's a 2. Okay, is that half of your degree of your leading exponent? Yes, so I can rewrite this one in quadratic form. Then I'm also going to go ahead and take it a step further and solve for x. So we're not just going to stop at writing it in quadratic form. Okay, so this is number 1, x to the fourth plus 13x squared plus 36. Okay, step 1, look at your middle exponent. It is half of the first exponent, so I can rewrite it in quadratic form. So the way you want to do that is I'm going just to divide this first exponent in half. Okay, and I'm going to put that inside the parentheses. So x squared is going to be inside the parentheses. And if I square that, then I'm going to get that exponent back. And then plus 13x squared, and I want the exponents inside the parentheses to match. They're both x squareds in this case. And then you have the plus 36 is your constant. Okay, so the notes are saying that I can say, okay, I'm going to reassign x squared to be a different variable. It's going to be v. Let me move this out of the way. So I'm going to substitute a v in for every x squared in the equation. So now it's going to look like v squared plus 13v plus 36. Okay, so now this is quadratic form, and I can factor it just like normal, we would normally. Okay, so I want to look at my constant. My leading coefficient is 1, so I don't need to take the leading coefficient times the constant because it's only a 1. But think of two factors of 36 that are going to add to be a 13. Two factors of positive 36 that add to be 13, be 9 and 4. So I can rewrite it, v squared plus 9v plus 4v plus 36. And now I can group and factor. The first two terms have a factor of v I can take out. The second two terms have a factor of 4 I can take out. And so I have the same binomials, so now I can consolidate v plus 4 and v plus 9. Okay, but then before you, this is not your final answer actually, you want to go back and put the x squared back in for your v. So write it in the same variable that it was originally, and your factors are x squared plus 4 and x squared plus 9. And so that would be your final answer once you put the original variable back in. Okay, let's try another one. Let's look at number 4. 2x to the 6th plus x to the 3rd plus 9. First step is to look at your middle exponent. It's a 3. And then we got to look at the first exponent. It's 6. Okay, is 3 half of 6? Yes, it is. So we can rewrite this one in quadratic form. So I'm going to take the first exponent and divide it by 2. Put the variable in parentheses, so that's x to the 3rd. And the squared goes on the outside. Okay, then plus, and I'm going to put x to the 3rd in parentheses, so the variables inside the parentheses have the same exponent. They match. Okay, so this is your quadratic term, this is your linear term, and then you have your constant. So if you want to, we can, again, substitute v in for x to the 3rd. Okay, that part is really up to you. If it doesn't bother you to have this x to the 3rd in the equation, you can leave it in there. It's, it's really your preference. I'm going to go ahead and substitute the v in for the x to the 3rd. So I have a v there. Okay, now this one does have a leading coefficient other than 1. So I'm going to take the leading coefficient times the constant, that's positive 18. Okay, 2 factors of positive 18 that add to be a positive 1. Well, there's not going to be any factors of positive 18 that add to be a positive 1. So this one is going to be prime. Okay, so all we can do with it here is write it in quadratic form. So sometimes in your assignment they're going to want you to rewrite in quadratic form and that'd be your answer. Sometimes they're going to ask you to factor if you can. Now the key word is if you can. So in this case, if they were wanting you to factor, you would say prime, because you can't factor that one. Okay, let's try one more example. Okay, this one is not on your paper, because I wanted to be able to factor one again with you. This is like number 7, but instead of having a minus 4 on the end, it's a plus 1. Okay, so first thing you want to do, see if you can rewrite it in quadratic form, because this is not quadratic. It does not have a square term, a linear term, and a constant. It has this weird fraction for an exponent. So I'm going to look at my middle exponent. It's 1/3. Is it half of the first exponent? Is it half of 2/3? Yes, it is. So I can rewrite this in quadratic form. So I'm going to take that first exponent and divide it by 2, which would make it 1/3. That goes inside the parentheses, and then the squared part goes outside the parentheses. So whatever it is divided by 2 always goes in the parentheses. Okay, so now I've rewritten it in quadratic form. Oops. So now let's see if we can factor this. I think that we should be able to. The leading coefficient is a 1. So 2 factors of 1 that add to be the middle coefficient 2. And that's going to be 1 and 1. Okay, so I can rewrite it. I'm just going to work this one without substituting a value in for my x to 1/3. You can decide if you like doing it that way or not. Okay, so I'm going to group my first two terms, group my last 2 terms. Now these first 2 terms have an x to the 1/3 in common. So I'm going to take out x to the 1/3, and that's going to be x to the 1/3 plus 1, because I had 2 x to the 1/3 for the first term. I only had 1 for the second term. And then my next 2 terms just have a positive 1 in common. So now my binomials are the same, they're identical, which is what I want, so I can consolidate my outer terms, x to the 1/3 plus 1. and write the binomial just one time, and those are my factors for that polynomial. Okay, so that's all I'm going to do right now. Why don't we take a break, come back, and I can show you a couple more examples. Okay, so I'll see you in a minute.